In our notes today, we worked some Punnett squares that have to do with sex-linked traits. So at the bottom here, for practice number 5, it talks about a trait that's on the X chromosome. It says, in humans, a gene for color blindness is located on the X chromosome with no corresponding gene on the Y. Determine the probability that 2 individuals will have a son that will be colorblind if their father has normal eyesight and the mother is colorblind. So let's first talk about the genotype of the parents. Now, if color blindness is a little b, to have normal eyesight for a male, since it's sex-linked, we're going to write XY, and so we're going to use a capital B to represent normal eyesight, since it's telling us that a little b is going to represent color blindness. And then it says that the mother is colorblind. Try that again. So to be colorblind, she's going to have 2 X chromosomes, and the only way that a female can be colorblind is if she has 2 of those recessive coats. So now let's go ahead and set up our Punnett square. Sometimes the male passes on the X and sometimes the Y. The female is going to pass on one of her X's to the next generation. Now we're going to bring them down, take them across. Okay, so it's asking offspring genotypes. And so in this situation, since these are the same and then these are the same, we would write 2 out of 4 X big B, X little b, and then 2 out of 4 X little b, Y. So then our ratio, because we really haven't answered this question if we just have it in fractions, is we could either say it's a 2 of X big B, X little b, to 2, X little b, Y. Or if we reduced it to 1/2 and 1/2, then it would be a 1-to-1 ratio. Just remember that before you get a ratio from your fractions, make sure your denominator is the same, and then you just take your top numbers. So let's look at offspring phenotypes. Now, since it's sex-linked, you're going to have to identify sex and whether they have the trait or not. So we have 2 out of 4 females, and they have normal eyesight. 2 out of 4 males that are colorblind. And again, this ratio, because it's going to be asking for a ratio in this situation, we would say it's 2 to 2, or we could say that it's 1 to 1. Now, this question up here is saying determine the probability that 2 individuals will have a son that will be colorblind. So we have a 50% chance that if they have a child, it's going to be a male that is colorblind. 2 out of 4, 50%. Now, on to the next problem. On the next page, it says the gene for hemophilia is recessive and found on the X chromosome. The dominant form codes for that normal blood clotting protein. Cross a female who is a carrier of the disease. So again, you need to remember that carrier means heterozygous. So since it's sex-linked for that female, we're going to put XX, and to be a carrier, she has to be heterozygous. She actually has normal blood clotting protein, but she could pass on to have hemoglobin to the next generation. For the male to not have the disease, then he's going to be X big H Y. So again, this female sometimes passes on this X or the other one. The male passes on an X or a Y, bring them down, take them across. And then it says it wants genotypes. So in this situation, I'm going to change that, if it isn't already on your notes, to phenotypes. Let's do phenotypes on this one. So as fractions, and since it's sex-linked, we're going to have to say 2 out of 4 female with normal clotting. I'm just going to put normal. And then I have 1 out of 4 is a male with normal clotting. And then 1/4 male that has hemophilia. So now as my ratio, it's going to be a 2 to 1 to 1. So we can write, or you can say 1 to 2 to 1. It just depends. If you say 1, you're going to have to say 1 male normal to 2 female normal to 1 male that has the disease, hemophilia. Okay, now that we've done those problems, you should be able to do this Punnett review worksheet that we see here. It's going to have just some regular Punnett squares, and it's also going to have some that are sex-linked. I want you to be aware of this first problem when it says we have a male with dimples and we have a heterozygous female. Now, just because I say male and female doesn't mean that you're going to break out the X and Y chromosomes. In this first problem, you should just be using L's. Big L, little l, and little l, little l. The only time you're going to bring out those sex chromosomes is if it says the gene is on the X, or this is a sex-linked trait. So again, just because it says cross males and females doesn't mean that you're going to be using those X and Y chromosomes in their genotypes.